Hello, my amazing advanced algebra students. This week, all you have is the quiz, the 6.1 to 6.4 quiz. I highly recommend you going over the review even before watching this because I'm just going to go through each of the problems on the review. Now, the quiz will be multiple choice, and there's 7 questions on there. You are going to be required to send in your work. So do your work. That'll be worth 4 points. So 7 points on the quiz, 4 points for the work, a total of, well, there's 11 points possible, but I'm grading it out of 10. Okay, so you can still get one wrong. As long as you're showing your work and sending that in, you will get 100%. So let's get started on this review. I decided not to go over number 1 because I didn't think you needed help with that one. And that'll be just like on the quiz. It'll be something, dare I say, easy. So let's start with 2, and it says, describe the end behavior of this function. So when you're seeing this, you need to kind of think, okay, I have an even exponent and a negative coefficient. Okay? What that means is the graph is going to be shaped something like this. Okay, so when the exponent's even, they're either both up or both down. Okay, we don't care about this other thing. This doesn't matter to us. Doesn't matter about end behavior. So when I look at this, I need to write this as x approaches negative infinity, f of x approaches negative infinity. And as x approaches positive infinity, f of x is again approaching negative infinity because they're both going down. Okay? So I would check these out because they're not going to necessarily be the exact same on the quiz. You might have a positive with an even. Okay, who knows? And then we'll look at the third one on here, which is really similar. You have an odd exponent though, and in this case a negative coefficient. So that's going to look kind of like this. Oh my gosh, kind of stuttered. All right, but it gives you an idea, okay? If it was positive, it would be going the other way. Okay? So odd exponents, they're going different directions. It just matters if it's positive or negative for the coefficient. So I'm going to write this out as x approaches negative infinity, g of x or f of x or whatever it is approaches positive infinity because on the left side it is going up. And on the right side, this is like hesitating. As x approaches positive infinity, g of x approaches, this time as x goes to positive infinity, f of x is going to negative infinity. Okay. The third one says evaluate f of 5 when given this piecewise function. So the first thing you do is you take this number 5 and see where it fits in. So look at the domain side of this. Okay, so 5 happens to fit in right here. Okay, because x is less than or equal to 5. Okay, it's not greater than 5. So that means we're going to use this and we're going to plug in 5. So instead of x, I write 5. So I have 15 minus 4. So I have 11. So f of 5 equals 11. And that's my answer. For numbers 5 and 6, you're going to have to write the rule when, in this case, when you have a horizontal translation of 4 units right. So remember, when it's a horizontal translation, that is going to affect the domain. Okay, so 4 units right, let's take this, and instead of writing an x, I'm going to write x minus 4 because that would indicate 4 units right. Okay. So then I just need to simplify that to x minus 8 plus 5. So 2x minus 3. So I'll start this up here. 2x minus 3. If x is greater than, and that's my domain. It went 4 units right, so I need to add 4 onto this 0. Okay. We'll do the next part of this, the 3x minus 5. Instead of x, I'm going to put x minus 4. And then minus 5. So I have 3x minus 12 minus 5. So I have 3x minus 17. And again, instead of writing less than or equal to 0, I have to add 4 onto that. Okay, so only when it's a horizontal translation do I need to worry about the domain. Okay. Let's look at the next one. This one we need to do a vertical translation of 5 units up. Okay, do not worry about the domain. The domain will stay the same. So let's take x minus 7, and 5 units up, I'm just going to plot plus 5 at the end. When I simplify that, that's going to just be x minus 2. And my domain will stay the same. And I'll do the same thing with this. 2x minus 7 plus 5. So 2x minus 2. If x is less than or equal to 0. Okay? So that one's pretty sweet. And the last one here is where we talk about the x and y intercepts. So first you have to figure out the x and y intercepts of f of x, and then when the transformation is done to it, it's called g of x, and you need to figure out the x and y intercepts of that. So my y-intercept, so I'll do my f of x. My y-intercept is that nice and easy one, that's 4. To find my x-intercept, I have to put 0 in for y. Okay, and I'll subtract 4. I'll do it over here. So 0 equals 1/3 x plus 4, subtract 4, and then multiply by 3. So my x-intercept is negative 12. Now for my g of x, I'm doing a vertical translation, or I'm sorry, a vertical stretch by 3. When I have a vertical stretch, my x-intercepts will stay the same, but my y are multiplied by that factor. So my y will need to be multiplied by 3. That says times 3. That's terrible. My x's stay the same, and my y becomes 12. So this would be your answer, because I think they only ask for, wow, that's crazy, only ask for the intercepts of g of x. What are the x and y intercepts of g of x? Okay, let me know if you have any questions. You definitely want to have your notes for this part right here. And good luck, I guess. So, and then also have a great Easter weekend too.